two first disclaimer. One is that even if I may be introduced as an expert in AI, I'm just a human being. So basically, if something I tell today aren't accurate or up to date, or you have any resources to actually give me more information about what I say, don't hesitate, tell them to me. It will help me to become more expertise, I would say. Second disclaimer, quoting the Learning Planet Institute website, the R&D Unplugged series is rethinking the way we communicate about research within the Learning Planet Institute community. But today I won't talk about research, I will talk about research and development. And just like R&D can have several meanings, I will suggest that we frame it today. And research and development will be product development based on cutting-edge results from research. This is, I don't know if this is the definition, but this is the one that will apply today. Okay. So the missing piece of the AI research puzzle. Annalena and Shab, they asked me to come up with a catchy title, so I hope it does the job. And because we're going to talk today about generative AI, especially large language models, which are based on the Transformers neural network architecture, which is based on a seminal research paper from Google Research, dated from 2017, called "Attention is All You Need." I will apply the same formula today because your attention is all I need right now. And I will use my attention base. So here are some portraits of famous people who were recently featured in the Time 100 Most Influential People in AI, 2024. Going from left to right, we have Demis Hassabis, who's the CEO and co-founder of Google DeepMind. We have Sam Altman, CEO of OpenAI. We have Jensen Huang, CEO of NVIDIA. And not yet. So basically, it also shows that we have a perfect demonstration of gender diversity in this field. But that's not the topic of today. And the fourth portrait here is one person who could illustrate the missing piece of the AI research puzzle. As I promised you, however, if you want to know who's even behind this, you have to stay behind this. So that's my base. So since the end of 2022, the public release of ChatGPT, we all have been overwhelmed by a buzz around generative AI. So investments, research publication, product releases, it went at a tremendous pace that even people like me who work in this field couldn't follow. So if you want to have a synthetic, almost up-to-date overview of this, I invite you to read the AI Index 2024 annual report released in April by the Institute for Human-Centered AI by Stanford University. And coming from this report, I will use a few facts and figures from it. That's not me. So three figures. First one, $25.2 billion were invested in generative AI, private investments in 2023. That's a lot of money. Second number, 149 foundation models were released last year. So as a reminder, a foundation model, and I will quote Wikipedia, it's a model that is trained on broad data, generally using self-supervision at scale, that can be adapted, example given fine-tuned, to a wide range of downstream tasks. So GPT from OpenAI, Llama from Meta, Gemini from Google, Mistral from Mistral AI, DALI, Stable Diffusion, to name a few, those are all foundation models. 149 foundation models were released last year. It's more than 3 models. It's more than actually 1 model every 3 days. Yes?
How do you get classified as foundation?
Sorry?
How do you get classified as foundation model?
I don't I don't know if there's a grid or a committee to evaluate and say, okay, this is a foundation model. There's not. So it's a lot of models. And actually, if you get that into perspective of the training costs, because those models need to be trained, last year we reached unprecedented levels for those training costs. OpenAI is GPT-4. We don't have the real numbers, we just have an estimation. But the training cost was estimated to $78 million for GPT-4. And Google's Gemini Ultra, which is the latest model from Google, we have the real number, and the training cost was up to $191 million to train it. Random comparison, this number, it's 25% of the annual budget of Université Paris. So, with such high numbers, we could consider generative AI and LLMs as somehow the luxury sports cars of AI. They are powerful, they are well designed, they're expensive, and they are somehow useless for your grocery shopping. However, more and more organizations have been using AI in their projects. Just like using a sports car may not be the best choice for your actually day-to-day life, this happens. More than 80% of AI projects fail, which is more than twice the rate of failure for IT projects that do not involve AI. This number comes from a research report called The Root Causes of Failure for Artificial Intelligence Projects and How They Can Succeed, Avoiding the Anti-Patterns of AI. It was published earlier this year, and to get this number, they actually interviewed 65 data scientists and engineers who had at least 5 years of experience to build AI models or machine learning models in industry or academia, or from companies of various sizes and industry. And their analysis highlighted 5 root causes of failure. Here they are. You can take notes. First one, intent and purpose of the projects unclear. Stakeholders tend to misunderstand or miscommunicate what problems need to be solved using AI. This is definitely not specific to AI projects, but AI models can be deployed while they have been optimized for the wrong metrics. 2, lack of data to train an effective model. It's simple, the organization may lack the necessary data to adequately train an effective AI model. And even if it should like common sense, it should sound like common sense, no data equals no magic. 3, focus on the latest technology instead of solving real problems. It's also common sense. But often we tend to focus more on the latest eye candy, shiny technology than solving a real problem for end users. It's an easy trap. 4, AI projects directly come with infrastructure needs, which can be, and they are still often underestimated, meaning that you can release a proof of concept, but as soon as you scale, the cost, they would just go up, up, and up, and you don't have then the infrastructure needed to deploy the solution you set up. And the last one, and I like it, it's like problems are too difficult for AI to solve, because even if we hear many things in the media, basically the ability of AI is still overestimated. So AI is not a magic wand, and we cannot solve everything by waving it. So my advice would be, before you fall into the massive trend of greenlighting AI projects because everybody does and want to be on board, take a few minutes and check how many bullet points you actually can tick. And doing that, you may avoid to fail by design. And notice that I haven't said you may succeed. You may avoid not to fail by design. It's different. So now that we have this grid to do some business relevance sanity check, I'd like to highlight something else about generative AI, which is not considered that often, and it's environmental costs. To do so, I will use two figures from a paper, which is very interesting. It was released end of last year by the team of Sasha Lucioni. The paper is called Power Hungry Processing, What's Driving the Cost of AI Deployment. Do we have, we have researchers here from other fields. I have a question for you, which is it specific to AI computer science field that the publication titles or the framework names are always puns like that? They sound like dad jokes, or is it like for every research field?
It's because ChatGPT that gave them.
Maybe. Anyway, so I will explain this graph. So the x-axis, you have different tasks. Okay, a task is something that you want to solve using an AI model. So, for example, the first one is text classification, when you want to classify text as spam, not spam, or anything else. You have extractive QA, so it's to answer a question using a text that you provide. So you give a text saying the birth date of Einstein, and the model is supposed to give you the answer because he has the answer in the text. Image classification, and at the end you have image generation. So this is what you have the different tasks in the x-axis, and the y-axis is the model emissions in gram of CO2. For the record, it's a logarithmic scale. So for those of you who may not be familiar with it, it's like you go from 1 to 10 here and to 10 to 100 here. In linear scale, it will be 1, 2, 3, but here you have 1, 10, 100. Okay. It's useful to actually display large scale data. So if we look at this graph, first, different tasks, different AI tasks, okay? Different amount of model emissions. Text classification is the cheapest one with 0.3 gram, but it goes up to 190 grams for image generation. It's actually 600 times more. So depending on the task you want to achieve, the cost won't be the same, definitely. This is the scale of model emissions, but the interesting part comes after, because in the task, you can see that there's, for example, the first one is text classification, and the 1, 2, 3, 4, 5, 6, and the sixth one is multitask text classification. What does it mean? It means that for text classification, you train a model to do only this. For multitask text classification, you use multipurpose generic models, and you ask this model to do some text classification. Simple example, you say, okay, ChatGPT, can you tell me if this block of text is spam or not, is about this topic or not? It's text classification. The model isn't trained for that specifically, but it can achieve the task. However, for text classification, it will cost 10 times more in CO2 emission. Second example, for extractive Q&A, the example I gave with Einstein's birth date. 0.4 grams, 6 grams. So it's 15 times more. And last one, because they compare only 3 different tasks, it's for summarization. So by summarization is already a more complex task. You can do it with a specific model trained for that, or with a multitask, multipurpose model. And if you do so, you will have the result. But once again, this will be more expensive on a carbon cost way. Second graph is this one. So we have more data here, so I will once again describe the legends. This graph is used to link the model size, the quantity of emission, and the accuracy for text classification. Here we use that we study the task which is text classification. Okay. So x-axis, the number of parameters, because the model is, as it's based on a neural network, it has many parameters. The more parameters you have, the heavier the model will be. Once again, it's a logarithmic scale. So it's the model size. Y-axis is simple, the text classification accuracy, so basically the performance of the model. It goes up to 1, and when you're at 1, it's your model is perfect. Okay. The quantity of emission, it's basically the size of the dots. Okay. So the bigger the dots are, the more they spend in CO2. It's once again a logarithmic scale, meaning that if a dot is twice bigger, it means that the quantity of emissions is 10 times bigger. Okay. And finally, the colors. The blue dots are task specific, so models train only to do task classification, while the yellow dots and the green dots are actually models multipurpose, so they can do many things. Actually, they know how to predict the next word usually, but they can also do text classification, but they are not dedicated to this task. Okay? We get 4 things for it. First one is that we have a wide diversity of performance for the task-specific model. Okay? It goes from 0.7 to 1. Second, we have less variation of accuracy for multipurpose model and a higher average accuracy. The average should be around, I would say, 0.93 maybe. And it goes basically from 0.84 to almost 1. So better results of the shell. Third one is that we have actually several orders of magnitude more emissions for multipurpose model, because we can see that the yellow and the green dots are always larger than the blue ones, and more than twice larger. And finally, for multipurpose model, actually, the better results are for the 3 billion parameter model, meaning that you can get more parameters, so heavier models, but for this task, they won't be the best one to choose. Okay? So now that we have more insights about the environmental cost of those models, that we have done a business sanity check for using generative AI, does it mean that we shouldn't use generative AI in products? I don't think so. I think that it's the right tool, but you have to ask yourself if the task that I want to achieve needs this tool. And I will illustrate that by showing you how we use it in-house so far within the WeLearn project. Yeah.
Just one question. What is the point in year 1 with like 5 million?
This one?
Yes.
I don't know by heart.
It is the best model.
For this task, yeah.
I'm not expensive.
No, actually, it's about. So WeLearn. For those of you who may be online and who don't know WeLearn, it's a project we've been working on at the Learning Planet Institute within the R&D department. And it's a digital platform used to navigate curated resources about sustainable development goals. This is a screenshot of its user interface, and it features a chatbot that you can use to ask questions about SDGs. And WeLearn will provide you with an answer based on the most relevant resources it has found in its database. So the question here is in upper scale. So what is the impact of climate change on the economy? The resources it found for this question on the right side. So we see the two first one, which is an article from the conversation and an article from Wikipedia. With the title of the resources, the corpus it's taken from, the author, when they have one, the time to read, a short description of the resource, and the SDG it's related to. And in the center, you have the answer of WeLearn, which is based on the resources it found. Okay? So I can hear you behind the screen. Okay, obviously, what's the point of using that instead of using a chatbot like ChatGPT, Gemini, or Claude? Well, to give you an answer, I think we have to give a look at what there is under the hood. So for those generic models, it's like that. You have a question about climate change. You put it in a black box, like ChatGPT, Claude, Gemini, whatever, and they give you an answer. And sometimes include sources. Still today, even the top-notch models can invent sources. They're getting more and more precise, but it still happens that among 10 resources they will use their answer, they will use to provide their answer, one will be completely fake. It's not solved yet. So it's a simplified version, and as you can see, it's crystal clear. Okay? For WeLearn, we have something a little bit more complicated, but it's still a simple RAG architecture. RAG stands for Retrieval Augmented Generation, and it's the most common use case for large language model application nowadays. So follow my lead. We collect data from different corpuses: Wikipedia, conversation, R&D Unplugged, IPCC reports, papers from HAL. We split them into paragraphs or chunks of text, because it's a process when you build a RAG architecture. I won't go into detail for that. Then you get chunks of text. You then vectorize them, because AI models, they need to work with, at the end, they need to work with numbers. So you need to attach or convert text into vectors of numbers. Using the vectors, you actually get a classification of SDG. So you know that this paragraph is about SDG 5, this one is about SDG 1. And you store that in a database, which is a vector database that we use for WeLearn. Then on the front end, you ask a question about climate change. A similarity search based on semantics will happen. So it will look into the database to find which resources are the more relevant to answer the question. Here it found for example, two paragraphs of documents. And you use a summarizer to provide the answer. Okay? We have two things here. First one is that I highlight in black and gray the parts that we don't know exactly how they work. For summarizing, we use a large language model, because even if we could build, and we saw this here, I talked about summarization and multi-tab summarization. So basically, we could use a custom summarizer model, but if we do that, we will have a summary, but it won't be framed or actually displayed as an answer to the question. To do this chatbot thing, it's more efficient and it sounds pragmatic to use a large language model. However, like I said, we don't know how it completely works. For vectorization, we use a lightweight model, but it's still something that we haven't built. Okay, so we use something else, and we convert text into numbers using something from a larger company, I would say. That's why it's great, because it's not as opaque as the summarizer. For SDG classification, actually, we built our own custom classifier. Because remember, text classification, it's useful, it's easy to do, basically. If you use a large language model, you could say, okay, tell me if this paragraph of text is about SDG 1, SDG 2, but it would be most costly from an environmental point of view. So we built our own, and with simple, old-fashioned machine learning models, we get good results. So this is an illustration of how we could use large language model efficiently. It's less black boxy, it's more explainable, it's sustainable, I would say. We have more control on the different layers. So it illustrates that even in 2024, an AI project doesn't have to be fully based on generative AI. You can use that, but use it with caution when it's relevant. So 11:30, yeah.
So you say that at the last step for the summarizer model, you're using a large language model.
Yeah.
But I guess you're not using the same kind, or you're using for like a very specific task. Like why? Like, how is it better than adding just the step of directly using the large language? Explain.
But for the summarizer, we use the large language model.
Yeah.
Because the summarization and the generation of the answer, which is not just a summary, it's an answer, okay? It's done in one step. If we would use a summarizer just to do summarization, it would generate a summary, but we would need to convert it to an answer in another way.
I think my question was that to me, intuitively, if you include a large language model at one step,
Yeah.
And here you're adding like 7 other steps to it,
Yeah.
that it would actually cost more environmentally than just using the large language model. So what's different here in the process?
So if I take the previous steps, for example, okay. If you like to use, if you want to do some LDD classification in the process, it's not possible because you need to get data from here in order to control the data you want to use for the answer generation. Okay, so my point is that both, the upper layer and the lower layers are separated. If you want to include only one thing in the whole process, like a large language model for several steps, you need to do it either in the upper layer or the lower layer. And here, what would we actually do before the summarizer using the same large language model? Nothing. Yeah.
Maybe I can give you another answer. You have millions of documents. If you wanted to do the exact same process with a corpus of, let's say, 100 documents, you could conceivably do it in the context window of the summarizer and do everything in one step, and it would work. But here you have millions of documents. So it's much larger than what the system could take in the context window. And even if it could, the computing cost would be so huge that it would make no sense. So here you have a first step where you look through millions of documents that you have categorized and analyzed. You take the 5 ones which are best, or 10 ones, and then you use this in your context window to generate them. So that's how the right system works.
Yes.
Also, I have a question. It sounds like the SDG classification tool is actually useful beyond WeLearn generally.
Yes.
I've not heard so much about that before as something that exists. And I was wondering, you talk is good, but what's the accuracy, what's the negative, where does it work well? Because you can find SDG on anything most of the times. People should also.
So it's this task of LDD classification is covered by several papers.
Okay.
The main problem with this task is that it's really dependent on the nature of the content. Meaning that if you want to classify an article or a talk or a research paper or whatever, it's difficult to have something homogeneous in the performance. Okay, and obviously there isn't much training data. So we gathered different data from basically the research paper we found. We train our own, and we obtain from a pure classification performance. For the binary classification, we're on the cascade, which would be above 0.9. And for the multi-label classification, so basically is this paragraph about SDG1, SDG2, SDG3, it depends on the SDG because some of them are, like you said, easier to discriminate. However, the main problem we face right now with this SDG classification is the language. In English, it works. In French, you have a decrease of performance.
And do you have also no SDG as a training set?
We use some actually. We use some, and but we use some from. You get basically random stuff.
You use random text.
One approach could be that we could use, and it's mainly done today. We could use LLM to generate synthetic data, but it's still not completely approved in the community. So.
Vicious circle.
So 11:37, and you're still there.
Yeah.
Yay! So it's time for the attention bait. You deserve it. So drum rolls, who is it? You certainly don't know her, or it would be very surprising.
Benedict.
Actually,
So that's what she's doing.
so this is Marie-Catherine de Barnef. She's an FNRS research associate at Université Catholique de Louvain. She's an associate professor in linguistics at The Ohio State University, and she got a PhD in linguistics from Stanford University. From our webpage, her main interests are computational linguistics and language acquisition, but I chose her mainly as an illustration of linguistics-based research on AI. And why did I choose to focus on linguistics? Well, if you remember the charts I showed you for the environmental costs, I said that large language models, multi-purpose models, they can do many things, okay? Text classification, question answering, summarization, but they haven't been trained to. They can be reinforced for that. They can be fine-tuned for that. However, the core is still the same, predict the next word, okay? So these abilities, they are called emergent. And even if some studies show that those so-called emergent abilities, they don't emerge so suddenly, this is still the way we get them. Emergent behaviors in large language models or language models are discovered, not designed. This is taken from a very interesting research article called Generative Models as a Complex System Science. How can we make sense of large language model behavior? Very interesting. I recommend it to you. And what does it say? If I quote them again, instead of directly designing models for these purposes, we are now in the position of training general models with different structure, and we actively probe them for behavior. This means that we cannot predict emergent abilities that we haven't thought to measure before. And obviously, we won't think of all of them. For me, it's an issue. So how can we deal with this issue? I mean, can research tackle this challenge of understanding how these language model behaviors happen? Most AI labs already work on that from a mathematical machine learning perspective. A few of them have an interdisciplinary approach, and I think it's definitely mandatory. But my intuition is that we won't make it until we get help from linguistics. Why? For a very simple reason. Because all the magics that we don't understand yet is done through language. Text input, text output. That's how, under the hood, those models manage to handle this complex task. And as linguistics is a study of language, I think we need to study the large language model from their perspective, including other fields, but this one. if we want to observe and understand how those models communicate through natural language. So here are two definitions. I can let you read those, but on the left, we have computational linguistics, which mainly consists of using computational approach to answer linguistic questions. And on the right, we have linguistic computer science, which is using linguistic approaches to answer explainable AI questions. So there's a kind of symmetry between both, as it's mainly using the tools from one field to answer a question from the other. Okay. The trick is that the left one is the introduction of the Wikipedia article, but I invented the second one because it doesn't exist yet. And I truly believe this is the missing piece of the puzzle. So I would like to, in the future, to see if this prediction of this emerging academic discipline was right, and if we can have the puzzle of AI research finally complete. Lunch bag takeaway message. 1, think twice before launching an AI project and give yourself a chance to not to join actually the 80% of failures. 2, use generative AI only when it's appropriate. So when the task you'd like to achieve needs it. Obviously, it won't save the planet, but it will help actually. And we need all the help we can have. 3, in AI research, linguistics will be the new black. So my belief is that humanities, arts, and social science will have their revenge over STEM soon. And this would definitely help to balance gender diversity in this research field, and it would be a nice side effect to have. You can find all the resources here. Thank you for your attention, and I'm open for some questions.
Thank you, Jean-Marc, for the talk. So there were several questions before and in between, and I hope that was fine for you, but I guess it really directly went on to the topic. So now, if there's still any open questions, things that are not clear, now's the moment to ask them to Jean-Marc.
I liked your approach with the linguistics models, and I wondered if you knew about other linguistic LLMs that are developing around the world, because there's this one in Africa called the AI, and it started by a Black South African woman, and I'm a fan of her because I'm a South African woman too, but it's really amazing. She could also be the fourth person in that row of pictures, and and I think it's more of a comment than a question, but just to think about discovering these technologies and these innovations in all different parts of the world is a really exciting time in the development of AI.
I completely agree. For this talk, I actually did some research to find people who could illustrate my points and our labs, and I found a few ones. I mean, not labs not AI or machine learning labs, which include a person from this field. Lab really driven by joining several disciplines at the same level. And I also found one linked to the University of Cambridge called the CHIA. I don't remember the meaning of that, but it's driven by a woman. It's she doesn't come directly from linguistics, but she's really in between. And the approach they have is really broad. I mean, it's they have people from medicine, from psychology, from machine learning model also, machine learning, but it's really broad. And I think it's not like a nice way to say it, but I think that if we want really to understand how it works, interdisciplinary is definitely mandatory. And right now we don't have it. We have a main approach by mail, from a computer science field. I mean, you can have a look at some videos of different companies where they show the research team and you say, okay, 12 men, 1 woman.
She's a product manager.
So we need to have more balance in the field, in the gender to tackle this, because somehow it's a new species. We don't know how it works. And it gets more and more into our daily lives. So we need to have an adult or I would say a wise way to study it. Yes, that's it.
You said kind of like computer linguistics.
Yeah.
Is an interdisciplinary field of study. Could you say a bit more about what are the kind of like disciplines that you see as central? You already mentioned psychology, etc. And what kind of like research approach you would like see for this field?
There's not much right now. First, like I said, I don't know why it's not that common. Like I said, I frame it this way because computational linguistics already exists. So you have already a discipline which is a mix between both. And I think that people from computational linguistics could do the job. However, from what I know, usually it's only one way. It's using computational tools to do some linguistics, some study of language. But we need people who actually know how to deal with text, with word, with sentence, and everything behind that, and apply it to observe the large language model, because once again, they do their thing because they predict the next word. So it's done through language. Input, output is just language. Yes.
Sounds to me like psychotherapy. Like you're basically trying to have a conversation with the LLM to understand its behavior, and like basically self-reflect on like why are you doing what you're doing?
Yeah, I think the observation is a large part of it, and it could be this way. But first, it's definitely out of my field. I don't have this knowledge, so we need more collaboration to get people from, like I said, humanities and social science, to help people from AI and machine learning to have a wide overview of what they work on. And it could include that psychology, definitely.
Building on that point, right now, linguistic is probably the core thing that is needed, but with the emergence of multimodal languages, it might also be different because you don't feed just text, but you have images, videos, real world data, sometimes from captures that are different than what the humans can feel, like 3D senses or other things, or temperature or whatever. So in this case, we build a new layer of complexity, the black box that we don't understand, and we don't even have something such as linguistics embodying all these sentences to apply to this field.
I think the main proxy would be cognitive science, maybe, but it's like you're already in level 3. Let's first tackle the level 1, where we deal only with text, and it would be enough if we understand it.
Yeah. Okay, so first of all, thank you for making computational linguistics the star of the talk. It's been a while since I haven't been to an AI talk. There's a lot these days that even mentions linguistics. So that's my background, and I'm happy that you brought it up. Now, I understand what you're saying about how there's no point in using a bulldozer when a screwdriver does the trick, right? So a small, specific, like specialized model for your task. Do you think, that being said, that there is a place for doing research or building really large models? Let's say if we were trying to work towards what a couple of years ago would have been laughable, but today is more acceptable, like artificial general intelligence, from like a research standpoint, but also from a pragmatic standpoint. Do these models make it maybe more accessible for companies who don't have expertise in-house to use AI in their applications without having to build these models because they can't? Do you think there's a place for them?
I would like that there is such a place, but like you mentioned, definitely working on these models and experimenting on them becomes out of everybody's league. It's so costly that only the top-notch companies that we all know can really do huge investments in this question. However, those companies, they include people from other fields, but it's like, 1 or 2%. It could even sound like greenwashing, you know, like mind washing something, but I think we need, like I said, this interdisciplinary approach, because we need all people from those different fields to put together and think about it. But it's not the case right now. Like I mentioned, the CHIA, I don't know if it's huge. It already exists. It's new, basically. And this is the kind of, it's like I said, it's hosted a link to University of Cambridge. So that's the kind of place where this research could happen. But they don't have the horsepower that you can have at the companies which build the 149 foundation models.
I think also one thing is, I think what we need to increase is like respect for these other disciplines. When there are computer scientists that are purely computer scientists by training that work on the models, they kind of find reading through the data or sifting through it or reading through model output beneath them, and they just don't do it. I think that's kind of lack of respect for these other disciplines. And that's the main issue here.
Or lack of knowledge.
Sorry?
Or lack of knowledge.
Yeah, maybe also.
Qualitative investigation is really something that you don't know, right? It's very hard.
Yeah, they maybe don't even realize that that's something that they could do. I work with a lot of computer scientists that even read the model outputs, and then we're like, I don't know why, or the training data, and we're like, I don't know why the model doesn't work. It's like, did you read what you trained the model on? And they're like, no. So I guess they don't even think about it.
It's training. Yeah, there's a question online.
Maybe Monica, can you maybe ask it directly? Because I think there's something missing in the text in the end. Maybe that's easier.
Yeah, sorry, it was a very large question. First of all, thanks, Jean-Marc, for your talk. Very interesting, very nice. I was thinking of the case of generative hallucinations. These answers that are perfectly semantically understandable, but that make no sense at some point. So I recently attended a talk in which the presenter was making the point that, in fact, all the answers that are generated by Gen AI are hallucinations, in the sense that the words are chosen by statistical models that determine the chances of a word to occur in a given context. So implying that this is not how our mind works. And I would like to know, to your knowledge, is it accurate, or does generative AI models also take into account other parameters? Thinking of what you're saying in the end, does cognitive psychology and neurosciences do they also have a role to play in the development of the field?
So thank you for your questions. The answer to the last one is that those fields are definitely relevant and already included. I think in AI labs, they already have people from neuroscience of cognitive psychology. But like I said, it's a small part of the research team, while it should be actually properly distributed. And what you said about the way those models hallucinate or predict, this is still the case. Like I said, to do any task that we give them, they are adapted, they are fitted, they are fine-tuned, but at the end of the process, they generate the answer from a statistical point of view, one word after another. So my point is that, and like I said, we can have a look at how it works in the model. We have billions of parameters, and we could, and I think it's already done, they have a look at depending on the question, on the text generated, which parts of the neural network are active or not, which actually is definitely something similar to neuroscience. But they apply these kind of things to study and to observe the neural networks, the artificial neural networks. But they don't observe that. They observe the way it works, but they don't observe the way it, I would say in the sub-layer, it's somehow think. I don't think that we are actually near artificial general intelligence. But I think that we could discover really something important if we find the way, or if we understand the way those models think. Maybe we should invent a new word. Think may not be the word appropriate, but like I said, we cannot explain how it works. We just know that it was trained on a billion of, a huge amount of data, almost the amount of data that we generated as a species. It includes many parameters. So somehow it thinks, but it thinks in a way that we cannot understand because it doesn't think like we do. So if we apply the neuroscience grid to understand it, I don't think it will completely do the job. That's why we need also to understand, okay, how does it actually build a sentence? Is there a logic? Is there some kind of generative grammar behind it? How does it communicate? And if we do so, maybe we have a chance to understand how it works. But if we stick only to mainly to the mathematical point of view, we miss something. I don't know if it answers the question, but that's definitely my gut feeling.
Okay, only 2 minutes left. A last quick question, maybe?
It's a question. How do you understand the learning we learn?
What?
What does learn mean? We learn?
2 minutes.
No, because you know you described what the tool does.
Yeah.
And I'm trying to understand how that plugs into the concept of learning. How you understand that?
I fell into machine learning but machine learning is mainly a way to do some optimization, mathematical optimization, that's it. But you find a way to translate it into different tasks and different kind of data. But it's still optimization. Learning, I'm definitely not from the education field, so I don't know the theory behind learning. I won't go into this. I just think that those models, they still do optimization. I mean, if you have a look at the neural network, that's the point, that's what they do. But they, like you said, they manage to achieve tasks. And we could say that they learn it. We don't know if they learn it per heart, if they learn it in a different way that we do, but they do the job. We don't know how. And we definitely have less information about how they do the job that we do for humans. I think we understand more how humans can achieve those tasks than how those models can achieve those tasks. And that's a problem. That's mainly a problem because we infuse our daily life with this, but we don't understand it. Yes, guys.
Thanks for the, I mean, it comes as a surprise, your answer, because it's based on neural networks and very simple models of neural networks, actually. So
It's very simple.
compared to the real life.
Yeah.
Yeah. So when you say we understand better how it works for human, even the fact that neuron, I mean, I work on neuron, one neuron, nobody understands how it's connected to all the other neurons around. And then this is why in the LLM it's somehow very simplified, even though it's complex. And so there is some sort of a paradox where you say it's easier to understand a human and a machine, while the reality, the substrate is much more complex in biology than in the models that are used to AI.
Thank you. So I will correct myself from 2 minutes and say that it's not easier, but we have much more literature about that. While for this, as it's brand new and we only tackle from a small side of the spectrum, we miss at least the research. You're probably right. It will be it will be easier. However, I think that and this is definitely just my intuition or my point of view, we are dealing with something completely different. And just like it's easier for us to study how humans think than to understand how different species think. I think we deal with something like a new species. And because it's completely understandable for us, if we apply the human spectrum understanding to this, it would be a nice proxy, but we would also need to have people who study other species and who could actually say, try this, and this, because we're dealing with something else.
Okay, we will not go too much over time. There's still space for discussion, so you can still use Jean-Marc. You will stay here for yes, so feel free. To our viewers at home, I say goodbye. Thank you for joining us. Thank you, Jean-Marc, again for having us.
Thank you.
Thank you.